Section 3.3, increasing and decreasing functions, and the first derivative test. First of all, basically this gives you up here, this gives you a formal definition of what it means to be an increasing function or a decreasing function. Basically what it means is if we have a positive slope or we're increasing, what this definition is saying is my y value here is less than my y value here. It's obviously it's increasing. This function is getting bigger and bigger. All right, and the same thing for decreasing. If we have a negative slope, so if it's saying that my y value here is less than my y value up here, my slope is decreasing. Actually, I think it goes the other way. My y value up here, my first one, is greater than this one down here. The slope is decreasing. So basically, the easiest way to remember is whether we have a positive slope or a negative slope of that graph. And again, I don't think I have to do this, but a positive slope would be moving in this direction. A negative slope would be moving in this direction. All right. So what we do to test for increasing and decreasing functions, if it's continuous. So basically what this definition here is telling us, or this theorem up here is saying is that if our slope is bigger than 0, so if our slope is positive, it's increasing. If our slope is negative, it's decreasing. And if our slope is 0, then we have actually a critical point. Where, and what I said in our last video, our critical point is basically a point where our slope changes either from a positive to a negative or from a negative to a positive. All right. So here we go. Example 1. Find the open intervals on which x cubed minus 3 halves x squared is increasing or decreasing. By that theorem above, we want to find the slope and figure out where the slope is increasing or decreasing. So we better find the critical points, because the critical points will tell us where that our slope changes from positive to negative. So let's find our slope here. So y or f prime of x equals 3x squared. When I bring my 2 down, this is going to cancel out. So I'm going to have minus 3x. Let's find our critical points by setting it equal to 0. So I'm going to pull a 3x out as well. And we get x minus 1. Okay. To solve for 0, we say, well, when is this? We said both of these equal to 0. So 3x equals 0. And x minus 1 equals 0. So we know our critical points are x equal to 1 and x equals 0. So what we want to decide now is we're looking at the intervals. We're going to take our smallest critical point. So our graph is doing something. It's either going up, 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 up until it gets to 0 and then it's going to change, or it's decreasing until it gets to 0 and it's going to change. Regardless, we know that we have an interval from negative infinity to 0, where it's either increasing or decreasing. It's got to be doing something until it gets to 0, then it's going to change. Then we know we have an interval from 0 to 1. That it's got to be doing something, because the next change it makes is at 1, and then we got to figure out what it's doing after it reaches point x, or x value reaches point 1. All right, our point of 1. All right, so let's figure it out. Let's pick a point in this interval here to figure out whether it's increasing or decreasing. We can just plug it into the slope, and if slope's positive, it's increasing. Slope's negative, it's decreasing. All right, so let's plug in, I don't know, let's pick negative 1. If I pick negative 1, I get 3 times the negative 1 squared minus 3 times the negative 1. So I'm going to get a positive 1 here, so I get 3 plus 3, I'm going to get 6. Since my slope is positive, during this interval here, this entire interval, what this just said up top here, through that entire interval, it's increasing. All right, well, let's pick a point inside of here. 0 and in between 0 and 1, let's pick 1/2. I don't know, 1/2. If I pick 1/2, I have 3 times 1/2 squared minus 3 times 1/2. So I'm going to have 3/4. When I multiply those two, I'm going to have 3/4 minus 3/2. If I get a common denominator of 4, I'm going to get a negative 3/4. All right. So my slope is negative. I'm really not too concerned what my actual slope is. Negative 3/4 really doesn't concern me all that much. The biggest point is whether it's positive or negative. My slope is negative, so therefore we are decreasing in this interval. And then we got to check our last interval. All right, our last interval, we got to pick a point in between 1 and infinity. Well, let's pick 2. See what our slope is doing at 2. So when I pick 2 in here, I'm going to get 3 times 4 minus 3 times 2, which is 6. So I'm going to have 12 minus 6. I'm going to have a positive 6. Since my slope is positive, I know during this interval it will be increasing. All right. So what I provided down here is just a couple of guidelines for finding intervals on which functions are increasing or decreasing. First of all, find our critical points. All right, and then we'll set up our intervals. So until our first critical point happens, our slope isn't going to change. Our slope of our tangent line, our instantaneous slope is not going to change. All right, determine the sign of your slope. So whether it's positive or negative at a test value in between the intervals, and then use our theorem 3.5. So if it's positive, we know it's increasing. If it's negative, we know it's decreasing. All right. Along with that comes the first derivative test. All right. What we can do is we can use the first derivative test to find our extrema, our maxes or our mins. And what this is saying, if we find our intervals and at a point C, so we find a critical point at some point C, we find a critical point. All right. If it changes, if our slope changes from negative to positive, so my slope is decreasing, and at some point C, our slope all of a sudden changes from negative to positive, we're going to have a minimum. And the same is true the opposite way over here. If we find our critical point, all right, and we're increasing, our slope is positive, and all of a sudden changes negative at C, so at C it starts changing negative on the other side, we know that we're going to have a relative max. All right. So let's move on to example 2. It says find the open intervals for which 3x cubed minus 3x squared, 3 halves x squared is increasing or decreasing. Locate all relative extrema. If you notice, the difference between that first example I did and this example is just this part right here. We decided it went from negative infinity to 0, I believe, and from 0 to 1. And from 1 to positive infinity in my last example. And we show that this was increasing here. From negative infinity to 0 is increasing. We found that it was decreasing here, and then we found it was increasing again. So what we can tell now, is since it's increasing, decreasing, then increasing, we can figure out what our critical points. Remember, our critical points are 0 and 1. We can figure out whether 0 and 1 is a relative min or a relative max. All right. So I'm starting negative infinity, and it says I'm increasing until I get to 0. Then all of a sudden it changes to decreasing. So I know at 0 I'm going to have a relative max. And then from 0 to 1, so say this point is 0, right? I can actually draw a graph if I wanted. This point is 0. This is from 0 to 1, it's decreasing, but when I get at 1, all right, on the other side of 1, it's increasing again. So it looks like I have a relative min at 1. So 0 is going to be a max, relative max, and 1 is going to be a relative minimum. All right, using the first derivative test. Here's another example right here. Find the relative extrema of x squared minus 4 to the 2/3 power. Again, we're going to want to find our critical points. It looks like we're going to have to take our derivative and set it equal to 0. When we take a derivative of this function, it looks like we have an inside and we have an outside. We're going to have to do the chain rule. We bring our 2/3 down. We keep the inside the same, x squared minus 4. We decrease the power by 1, so negative 1/3, correct? And then we multiply then by the derivative of the inside, which is just going to be 2x. To simplify this, and then we'll set it equal to 0, so I'm going to have to simplify this on my top. I'm going to have a 2, and I'm going to have a 2x, so I'm going to have 4x on the top. And on the bottom, this negative exponent means I'm going to bring it down to the bottom. On the bottom, I'm going to have 3 times x squared minus 4 to the 1/3 power, which means the cubed root. Okay, and we're going to set it equal to 0. When we find our critical points, we're looking at what's going to make the function 0, and what also is going to make the function undefined. So what we want to do is basically we set the top equal to 0 and the bottom equal to 0. If the bottom equals 0, that's going to make the function undefined. If the top equals 0, as long, it doesn't matter what, 0 divided by whatever the bottom is, doesn't matter what it makes it, all right, it's going to be 0. So when we set the top equal to 0, for x equals 0, we know we have a critical point at x equal to 0. All right, well, let's figure out when the bottom equals 0. So the 1/3 power means the cube root. So I'm going to have 3 times the cube root of x squared minus 4. And I'm going to set equal to 0. I'm going to divide by 3, and I get 0. And I'm going to cube both sides, and I'm going to get 0 still. So I have x squared minus 4 equals 0. Add 4 to the other side. X squared equals 4. Take the square root, I get x equals plus or minus the square root of 4, which is x equals 2, and x equals negative 2. So actually I have 3 critical points. I have 2, negative 2, and 0. So we have our intervals. We start with our smallest, we write our intervals. So write our intervals. So from negative infinity to negative 2, it's got to be doing something. So negative infinity to negative 2, it's doing something. It's not changing until it gets to 2, until it gets to our critical point. Then from negative 2, it's doing something else until it gets to 0 is our other critical point. And then from 0 to 2, it doesn't change until it gets to 2. And then it doesn't change then until, well, ever. I guess it goes on forever to positive infinity. So using the first derivative test, we're going to find our relative extrema and our relative max or relative min. All right, so we need to check out this interval right here. Pick a point in that interval, and we'll plug it into our slope. And I don't know which one's easier for you. Maybe this one's easier. We'll plug it into my slope and figure out whether it's going to be positive or negative. Again, I don't care what the number is. I just want to know whether it's positive or negative. All right, so if I pick, let's say, negative 3. If I pick negative 3, that's in this interval right here. Pick negative 3, and I'm going to have negative 12 all over. Looks like I have 3 times 9 minus 4. The cube root of a positive number is still going to be positive. Still times a positive. I'm going to have a positive over a negative. Really, you just have to worry about the signs. I'm going to have a positive over a negative. So that means my slope is going to be negative. So I'm decreasing here. Same thing. Pick a number between negative 2 and 0. So pick negative 1. All right. Even when I pick negative 1, I'm going to have negative 4 all over 3 times 1 minus 4. To the 1/3 power. The cube root of a negative is still a negative. So I'm going to have a negative all over a negative. So that means I am increasing on this interval right here. Pick a point between 0 and 2. I'm going to pick 1. When I pick 1, I'll have, and I plug it into here, when I pick 1, I'm going to have 4 all over 3 times 1 minus 4. The cube root of 1 minus 4. So the cube root of negative 3. All right, again, I'm going to have a negative on the bottom and a positive then on top. So I'm going to have a negative slope, so it is decreasing. All right, and then I got to pick 3, another value that is in our last interval right here. Pick 3. All right, so I'm going to have, when I pick 3 and plug in here, I'm going to have 12 all over 3 times 9 minus 4. So I'm going to have a positive in my cube root, or to the 1/3, sorry. I'm going to have a positive all over a positive, so I know I'm increasing right here. Again, now we just use our first derivative test, and sorry I'm rushing through this, but I'm running out of time for YouTube. All right, we look. What is it doing at negative 2? Well, before it gets to negative 2, it's decreasing, and then when it gets to negative 2, it changes to increasing. So at negative 2, we are going to have a minimum. All right, and then we look between negative 2 and 0. What's it doing? It's increasing until it gets to 0. All right, until it gets to 0, and then on the other side, on the right side of 0, it's decreasing. So I'm going to have a maximum at 0, a relative max. All right, and then I got to figure out what it's doing at 2. So now it's decreasing on the other side of 2. From 0 to 2 is decreasing, then at 2 all of a sudden it changes to increasing again. So I know that 2 is going to be a relative minimum. I'm sorry I had to rush through that, but I actually only have about 20 seconds until YouTube won't let me upload anymore. I hope this made sense, and we'll see you in class.